Hello everyone, my name is Dhruv Patel and I have created this project as a part of the Visualization course offered at the Chennai Mathematical Institute. This dashboard was built using R-Shiny and focuses on the topic of educational inequality. The motivation behind choosing this topic is the ongoing global debate regarding school resources. Does simply pouring more money into the educational system guarantee better student outcomes? My aim was to use data science to move beyond assumptions and identify the actual structural drivers of student success. Moving to the data description tab, the dataset used is the educational inequality data sourced from Kaggle. It contains 1000 observations where each row represents a unique school. As you can see in the data dictionary I created, the attributes encompass financial metrics like funding per students, structural factors like school type and student-teacher ratio, and performance metrics like average test scores. Below the dictionary, I have included a raw data explorer that allows user to search and filter the dataset directly. Now, let's explore the visualizations. The first step is the geospatial analysis. Here, I have plotted the average test scores across the United States. Darker blue regions indicate higher average performance. On the right, the top states table ranks jurisdictions by their aggregated scores. We can observe that states like California and New York are outperforming others, suggesting regional clusters of educational quality. Next is the school type analysis. This section highlights the structural differences between institutions. First, the pie chart shows the composition, revealing a balanced mix of roughly 33% each for public, private, and charter schools. Next to it, the histogram shows the frequency distribution of scores. You can see overlapping areas, but there is a distinct color for each type. The most critical insight comes from the box plot at the bottom. Contrary to popular belief, this plot reveals that private schools, charter schools, and public schools have nearly identical median scores. The variance or the spread of the data is also similar across all three. This is a significant finding. It suggests that in this specific dataset, institutional type is not a strong predictor of academic performance. Moving to the financial impact tab, this is a central to my research question. Does money buy grades? I have plotted scatter diagram funding versus test scores. Crucially, I have fitted 3 separate regression lines, one for each school type. Notice how the lines are relatively flat and parallel. This indicates funding inelasticity. It suggests that regardless of whether a school is public or private, simply increasing the raw funding per student does not result in a proportional increase in test scores. In the socio-economic factors tab, we look at external factors. On the left, the income versus score scatter plot investigates the link between poverty level and performance. Surprisingly, the data shows a high degree of variance, meaning some schools succeed despite socio-economic headwinds. On the right, the dropout density plot visualizes where dropout rates cluster. The peak indicate the most common dropout rates across the different school types. Finally, the correlation matrix. This heatmap visualizes the Pearson correlation coefficients. I have fixed the color scale so that white indicates zero correlation. As you can see from the numeric values inside the boxes, most correlations, even between funding and scores, are nearly zero. This statistically confirms our earlier finding that performance in this dataset is highly independent of simple financial inputs. To conclude, this dashboard challenges the blanket funding hypothesis. The analysis suggests that institutional structure plays a larger role than the raw investment, and that public schools require structural reform rather than just budget increases. I would like to thank my guide, Professor Sourish, for his support throughout this project. Thank you.